Hi, math lovers. Welcome to notes number 43. We're on lesson 2.3. We're going to talk about analyzing graphs of functions. So today, let's try the vertical line test. The vertical line test says that if you drop a vertical line anywhere on a graph, that graph is only going to get intersected one time by your vertical line. If it only gets intersected one time, then it's definitely a function. So like this one, let's start with this line. If I drop a vertical line anywhere here, I'm only going to hit my line one time. So we say, yes, this is a function, definitely a function. Over here, if I drop a vertical line, I've crossed the function two times. So this one is definitely not, okay? Now, so you've got to think about these other ones. If I drop a vertical line anywhere I want here, am I going to hit this graph more than one time? This one, notice open circle and a closed circle. So yes, this one is a function, okay? Here I've got a nice parabola. I didn't really draw it perfectly. You know, it is just a sketch, but we know that the parabola is going to ever more slowly go out and out and out. So if I drop my vertical line at any one x value, it's only going to hit it one time. So this, yes, is a function. How about over here? Notice it's similar to this one. Now I've completed I colored in the circles. So if I drop a vertical line, I've hit the graph two times. So my friends, that is not a function. And the last one is an absolute value graph. Yes, that definitely is a function. I'd only intersect the graph there one time, okay? So the next thing I want to go over with you is the zero, okay? Lots of people call it the same, different names. The zero, okay? The zero is the same thing as the root, okay? Which is the same thing as the x-intercept, okay? So what I'm saying here when I say the zero, go back to your function machine, and oh, you know how much I love drawing this little picture, okay? The number that I'm going to be putting in is called the zero, okay? The number that comes out is zero, all right? So when I say find the zero, I'm saying what number for x will make y equal to zero, all right? So we want you in number 30 from your textbook. We've got f of x is equal to 9x to the fourth minus 25x squared. You know how I love those factoring questions, don't you? Okay, so we want to figure out where this graph is going to cross the x-axis. So straight up, I'm going to set the whole thing equal to zero because I'm finding the zero. Every year there's a kid who says, wait, Glennon, you mean the zero is equal to 4? I was like, yeah, the zero. It's not, I'm not saying 0 is equal to 4. I'm saying the 0 is equal to 4. Okay, so I've got 9x to the fourth minus 25x squared. Well, you can straight up factor that one, can't you? So let's see, GCF will be x squared. So it'll be 9x squared minus 25. Factor that one again. So I've got x squared, 3x minus 5, and 3x plus 5. Okay, fabulous. So now you're going to solve that. Set each factor equal to 0. X squared equals 0. 3x minus 5 equals 0. 3x plus 5 equals 0. So I know x equals 0. X equals positive 5/3. And this over here would be negative 5/3. Okay? Now, this root, this one's special. Okay? This is what's called a double root. Double root, all right? Take your calculator out, and you guys are going to graph this function on your calculator, okay? Go ahead, take out your calculator. Okay, oops. Clear it from the last one I did. 9x to the fourth minus 25x squared. Okay, so ready to graph it. So I'm going to hit the button that says graph. Okay. Now, a lot's going on in here in this graph. A lot is going on. the graph is going to, if I could just shrink it up a little bit for you, all right, the graph is going to come down here. At some point it's turning around. It's going to go back up like this, okay? So I want to know what the coordinates are right here. That's what I want to know. And you know what we did? We found them right here. It's going to cross at 0. It's going to cross at -5/3, and it's going to cross at +5/3. Isn't that great? All right. So what you can do on your calculator is up here where it says in blue calc, you do second calc, and you want to find the 0. So go over here to where it says 0. All right, now this gets a little bit tricky, so make sure you have your calculator out as we go through this, all right? Pause the video if you need to. I want to find the 0. Now, you can see this little spider. You can see this little spider, he's flashing, all right? Saying, hey, where do you want me to look for the, I want to where this coordinate is over there. So I'm going to arrow the little spider down so that he is on, I lost him. There he is. So he is on the left of where I want to intersect. All right, I want to do it there. And it's saying, hey, what's the right bound that you want to use? So just go to the other side of it, okay? And saying, hey, should I calculate between here and here? Should I guess now? And you say yes. And it did it, okay? So here we are at -5/3. The little spider here, that's the point they're talking about. Now, calculators used to just go ahead and go calculate all the coordinates. It would take forever. So now we're just narrowing down the part of the graph. If you have one of those fancy colored ones, the colored TI-84s, they will put the lines, they put little lines in there to show you where you're actually calculating. What I want to point out to you is this double root. Do you see how the graph intersects at -5/3 and then it comes back up and it touches at 0 and then it turns again? This is double root. Is it a great feature because it's going to touch the graph and then it's going to turn. Couple things else for you to notice. Notice your highest power here is 4. So it's going to intersect the graph at most 4 times. All right. It actually does it 3 times because 1 is a double root. And the other thing I want you to notice that A is positive. All right. So this 9 is positive. So we're going to open up. Our exponent here is even. So our end behaviors are the same. All right. And of course they're positive. All right. So have fun, my darlings, with your problem set.